All right, moving on. Here we go. Keeping it real. We did 1-4. You've done 1-1 through 1-4. Remember, 1-4, you had the question on how do I isolate or get the variable, the unknown, by itself. And we saw some things to make that easy. Today in 1-5, good news, good news, good news. You're using all the same information. Using same information, or what we call methods, to solve for unknown. Remember, unknown being like x, right? I'm solving for x. That's all you're doing. But today we're going to be introduced to the inequality. The inequality, not equal, hence inequality. So in 1-4, we're looking at the equal sign. Now we're looking at the inequality sign, which, if we recall, less than, greater than, less than or equal to, greater than or equal to, and not equal to. We don't really use not equal to very much. We will later, but not now. And the trick, I don't know if you remember this, but just in case. Which number is greater? Come on, computer, you can do it. You can do it, computer. Maybe. I don't know why this is taking forever. You get it, right? We're lagging. Things lag. If I have 8, if I have 4, which number is greater and what symbol do I use? 8 is greater than 4. And so remember, I always remember it as the mouth eats. The mouth always eats the larger number. So if you even want to draw some sweet little fangs in there, yum, 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 yum. Rah. And it's going to eat 8 because it's the bigger number. The inequality, hungry for the larger number. We also have something like use an inequality, like let's say 6 and 6. Obviously they're equal, but we're not using the equal sign. So in this case, the inequality can be either this one or the other direction, but we have to have the symbol. This means equal also. Anytime we have that line underneath, it means it could also be equal. And so this is a true statement. 6 is greater than or equal to 6. So that is true. Let's use that information now to fill out our notes. You can go ahead and pause this and kind of look it over. But like on this first part, what would we use for less than or fewer than? We're going to use this inequality. As if I'm reading from left to right, this would be a less than. And below it, greater than, being the other direction. And again, if we had less than or equal to, we would have less than, equal to, or greater than, equal to. Sure. You can pause the video, kind of look this definition over. And at the bottom, it's going to ask you, hey, can you fill some of this stuff out using the inequalities? So notice on 4 through 5, all of those, it starts with 10 being greater than or equal to -3, and that makes sense. 10 is larger and bigger than -3, but what happens when we flip those things around? Notice -3 is first and 10 is second. How would I write my inequality? Same inequality, but remember, the greater one gets eaten. So keep the mouth facing the greater number, and you'll be fine through this whole lesson, guys. All right? Even on the next part, -7 is less than -1. And if you thought of a number line, all right, remember, greater is as we go to the right of a number line, numbers get greater. So if I looked at -1 and I looked at -7. Oh, -1 is greater because it's farther right on the number line. And so -1 is greater, but when we flipped the numbers around, we keep the inequality. The mouth, notice the mouth, it's eating, those are teeth, and it's eating the larger one. So in this case, it's eating -1. All right, cross out the equation. I'll let you guys do 4 and 5. Here on number 6, it's saying that x equals 3. Looks like we might be lagging. All right, let's try something real quick. All right, we are back online, I think. Sorry about that, guys. Good news is you're watching this on a video. You could just fast forward through that whole process. Number 6, though, it looks like if we have x equals 3, we're plugging that in for x and seeing which of these is true, which one of these are actually equal. And you'll do the same thing on number 7. You're plugging in x is less than 3. So which one of these, cross out the ones that are not true. Like, for example, if we know that x is less than if x is less than 3, that could be, x could be 2. X could be 1, 0, -1. So in this first part, is it true? Is x still less than or equal to +3? Yeah, it is. What about this one? If x is less than 3, can x be less than or equal to 1/3? Well, yeah, 1/3 is still less than 3. And here, what value, if x has to be less than 3, what we can do is we're going to solve for x. Or we're not there yet. Let's plug in values. Let's say I plug 3 in for x. I can plug in 2 for x. I can plug in any number that's less than 3. And is it true that this side is going to be greater than or equal to 5? Well, if I start plugging in all these values, I can plug in 3, and what do we get? We get 3 plus 2. Is that greater than or equal to 5? And in this case, it's true. It's true only in the sense when x equals 3 that would be true. Now, if it said something like, is it strictly greater than 5, we would say no. And on this last one, if we plug in this value of, let's say, 3, is 3 plus 2 or 5, is that less than or equal to 5? That's true. And then if I plugged in 2, and if I plugged in 1, if I plugged in any value less than 3, no matter what, it's still always going to be less than 5. And so I'm going to go ahead and apologize now, because this is not true. It's only true, I'm sorry about that, I'm glad we went over this one. This is true if I plugged in 3, but is it true if I plug in any value other than 3? If I know x has got to be any number less than 3, what if I plugged in 2? Is that less than 3? Yeah. But is this true? Is 2 plus 2 greater than 5? No. And if I plugged in 1 here, is 1 plus 2 greater than 5? No. So this is 100% not true. And I apologize for that misunderstanding on that. All right. So now how do we solve inequalities? The good news, guys, it's the same as solving an equation. There's a couple little things that we'll go over as we go along, because there are a couple differences, but for the most part, it is identical. All right. It's 100% identical. And so if we look at the subtraction property, notice if, like an equation, what I do to one side, I have to do to the other. Here we have 3 greater than -1. Here we have 3 plus 5 greater than -1. Guess what? We'll have to add 5 to the other side to keep everything balanced. On number 9, if I have 4 is less than or equal to 9, here I have 4 plus n. So look, I'm adding n to this side. That means I need to add in to the other side. So whatever I do to one side of the inequality, I must do to the other. Even here, z is less than 8. Notice we're adding, or in this case, I guess you would say subtracting all of that, -4. It's kind of trying to be a little ridiculous just to prove that, hey, what I do to the other side where there's an 8, I have to do it here as well. Again, w greater than or equal to k. We have w minus t, so guess what? I need to minus t on the other side. Here we go. One, we're going to solve this, and I feel like a lot of you will be fine with solving this. Graphing it, that's an interesting story. And so we're going to get a lot of practice on how to graph these things. Okay? For now, I'm not worried about this. We're going to do our own thing. N minus 5 is less than -3. So if I want to find n, guess what I need to get rid of? I need to isolate n, just like with the equal sign. So -5, I need to add 5 so that they cancel. But what I do to one side, I have to do to the other. And now I get n. Notice my inequality. We will not change the direction of the inequality. Not for now, anyway. And what we have is -3 plus 5. If you've been doing the number line, we'll start at -3. And plus 5, meaning I'm going to go 5 in the right direction. So 1, 2, 3, 4, 5, ending up at +2. So instead of an equal sign, notice we did the same thing, except we kept the inequality. And we kept the inequality pointing the direction, the same direction. Let's look at our answer. N is less than 2. Notice that n could be a lot of numbers, right? How many numbers are less than 2? Infinitely many numbers, right? If we continued down the negative number line, it would go to -infinity and on and on and on. So how could I represent that? Instead of saying as a graph, how do I represent that? What we'll do is we know for a fact we start at 2. So on number 13, you've got 4 options to choose from. For example, let's look at this guy. Does that graph start? We know it has to start at +2. Does this graph start at +2? It does not. Okay? Let's look at this graph above it. Does it start at +2? Close. It looks like it starts, if you notice, that's at -2. But we need to start at +2, so it's not that one. Here, does this graph start at +2? Look at this final graph, and let's take a moment to look at that. One, it starts at +2, and notice the line shows you that those are all the numbers that's less than +2. And here's a little hack for you. You ready? If I wanted to represent all the numbers less than +2, I would start at +2, and I would go everything less, or everything to the left. Notice your inequality is a kind of like an arrow, and it's pointing the direction that you need to go. That's only true whenever we solve and our variable is on this left side. So there's a little math hack for you. I'd rather you just realize, all right, all numbers that are less than 2 has to look something like this, because I start at +2, and everything less than 2 would be everything to the left. But if you can't remember that, a little hack is that little arrow shows you which way you need to shade your arrow. Another good question hopefully you've asked, why is that an open circle instead of just a dot at positive 2? Notice our inequality doesn't say that it's equal to 2. It starts at 2, but it's not equal to 2. So to indicate that I'm at 2 but not equal to 2, I have to indicate that with an open circle. And you'll see in a second, when is it closed? Let's see if we can answer that question. When do I use a closed circle? Here we go. We're going to solve it and graph it. If I want to get m by itself, then I need to get rid of negative 11, so I'll add 11 to the other side. And here I'll have m. I'm not changing the direction of my inequality, and I have negative 2 plus 11. And if you do a number line, or if you just solve it, you get positive 9. So that will be not too new information. What's new is how do I graph that? Well, regardless of how I graph this, I need to start where? Looks like I need to start at positive 9. So I've got a number line drawn up for you. If you follow that, looks like positive 9 is going to be right here. In fact, I'll put a 9 there just to indicate it. Now notice the inequality. Notice the fact that it's also equal to 9. So I'm not going to put an open circle at 9. I'm going to put a closed circle because it's equal to 9. And what is m in relationship to 9? Remember, the inequality eats the larger. So m is all these numbers that are larger than 9. All numbers greater than or equal to 9. How would I indicate that? Which way would my arrow go? Am I going to go this way or am I going to go this way? Or which way indicates greater than 9? That would be everything to the right. Try that again. That would be everything to the right of 9. And a quick tip, notice the inequality is kind of like an arrow showing you which way to go when it comes to graphing this. All right. Let's try another one. Just some more practice before you start your homework. Homework's going to be a lot like this as well. Solving for y, got to get rid of positive 12, so we subtract 12 to the other side. Inequality does not change direction at all. I still have y on this side. Here I have negative 12 minus 1 or negative 13. You can leave your answer like that. If you like to write it where y or your unknown is first, you can. Just remember the inequality stays the same direction. It's always trying to eat negative 13. Now graphing this. I'm not sure. I'm kind of hazy on what direction my graph needs to go, but either way, we need to start at negative 13. So on this graph, this would be 0. Here's 10 and 14, so that makes this 12. So 13 is going to be, or I'm sorry, negative 13 is right here. Open or closed circle? Well, because it's equal to negative 13, we're using a closed circle. And this is why I'd rather you understand the meaning, the definition behind inequality. Because look, y is all the values less than negative 13. According to my inequality, all the values of y is everything less than negative 13. So if we look at our graph, which direction would be less than negative 13? Well, we get less as we go to the left, so I need to make my graph point this direction. Hey, notice how that contradicted our little hack. Notice how this looks like it's pointing to the right. Don't I go to the right? That only works if you had it set up with your variable or your unknown on the left side. So if I rewrote this so that my variable is on the left side, Notice y is still less than or equal to negative 13. Now it does look like the arrow and it points the direction that we want it to. So I'd rather you just understand the inequality and what it means, but if not, as long as you write it to where your answer looks like this, the variable's on the left, then the arrow will always point you in the right direction. All right, here we go. Word problem, we got a club. Go ahead and pause, read this. That's the problem with word problems. People usually just like, word problem, I quit. Read it and just try to understand what's going on. Okay, you've read it, you paused it, you read it, right? Things I like to look for as I go through this is, well, one, notice that there were 25 plants. You're trying to sell at least 25 plants. So there's a total. Love totals. A club member sells 8 plants and then 9 plants. What are the possible numbers that they can sell on the other day? So if you've read this, it's like, okay, they've sold plants these 2 days. How much do they need to sell on that third day so that we have at least 25 plants? Okay? So if I had to make an equation, and I'm not going to make an equal sign yet, I'm going to wait. I know that I'm going to have what? I'm going to have 8 plants that I sold on Wednesday. I'm going to add that to 9 plants that I sold that I sold on Thursday. And I'm going to add that to, I don't know, let's call it X plants for Friday. Well, you see it right there. But either way, it all has to come to a total of 25. All right. Now, if I said it had to equal 25, we just put an equal sign there. But here's the goal. You want to sell at least 25. So you have to kind of understand, if I wanted to sell at least 25 plants, is that okay if I only sold 1? No, because I want to at least. That means whatever I sell has to be greater than or equal to 25 plants, according to this. So when I write my inequality, I want to look at this guy right here. And a good way to try that is, let's just put some stuff in here. Let's say I did this one. Don't do that. Just listen to what I have to say. If I add all my plants up, according to what I'm trying to say, is I want to add all these up and I want to make sure that I'm less than 25. That doesn't make sense. If I want to sell at least 25 things, I want to sell everything more than or at least 25. So if you put an inequality, see if it makes sense. Let's see if this inequality makes sense. Everything that I sell on all 3 days, I want it to be greater than or equal to 25 plants. Now that does make sense. So now that I have my equation, I can rewrite it as greater than or equal. I'm too much in the habit of writing the equal sign. Here, I want to simplify. I can add these two things together. So 17 plus x greater than or equal to 25. Getting x by itself means I need 2. Notice I'm not changing the inequality sign at all. And what's 25 minus 17, I believe, is 8. So that means if we've sold this many plants on Wednesday and Thursday, I have to sell at least 8 plants to make my 25 goal or higher. All right. Guys, a lot of this is what we just did. I don't know that you really need a lot of my help on this, but let's just say graphing. On that first part of the homework, it just wants you to solve it. Don't worry about graphing it. But now it wants you to solve and graph. So let's look at what I'm looking for. Jump down to number 10. Again, to solve it, looks like I need to get rid of, I want f by itself. So let's subtract 4 to to the other side. So we have f. I'm not changing the inequality at all. 8 minus 4 looks like positive 4. You've solved it. There you go. But now graphing it. All right, anytime you do a number line, always indicate 0. Always. I don't need 20 little marks and you counting up to 20 on the right and 20 little marks going to negative 20 on the left. I just need to know where 0 is and where you're trying to start. In this case, positive 4. 1, 2, 3, positive 4. That's all I need on your number lines. Now we can solve and graph it. According to this, am I going to have an open or closed circle at positive 4? Looks like a closed circle because it's equal. And now I read my inequality. F is greater. Remember, mouth is greater. It's eating the greater. F is greater than 4. So if I had to draw an arrow that would indicate numbers that are greater than 4, which direction am I going to go? Hopefully, if you realize on a number line, we get greater as we go to the right. So all numbers greater than positive 4 would look like that. And that's the graphs that I'm looking for. All right. Again, we'll meet up in class, go over any questions you want, guys. All right. And I'll see you then.